This video is about section 7.2, estimating a population mean. In chapter 6, we studied that the mean is an unbiased estimator, which means the sample means target the population mean, so that the best point estimate for the population mean mu is the sample mean x bar. And the confidence interval for the population mean mu is the sample mean minus e, which is the margin of error, to the sample mean plus e, the margin of error. Or you can say the population mean is greater than the sample mean minus the margin of error, less than the sample mean plus the margin of error. How do we calculate this margin of error E? Well, there are two cases. The first case is if the population standard deviation sigma is unknown, then the margin of error E is equal to T alpha over 2 times S divided by square root of n, where this S is the sample standard deviation because the population standard deviation sigma is unknown. N is the sample size. We'll talk about what is T alpha over 2 a little bit later. The second case is if the sigma, which is the population standard deviation, is known. Well, this is a very rare case because usually we use the population mean to calculate the population standard deviation. So if the population mean is unknown, we need to estimate that. That means we shouldn't know the population standard deviation. So the second case is very rare and unrealistic because we don't know the mean, population mean, but we know the population standard deviation. Anyway, if it is this case, then the margin of error E is equal to Z alpha over 2 times sigma divided by square root of n. Since the second case is very rare and unrealistic, in this class we do not discuss this case. We'll only talk about the first case when sigma, which is the population standard deviation, is unknown. Then the margin of error is equal to T alpha over 2 times S divided by square root of n. Now, what is this T alpha over 2? So here we will introduce a new kind of distribution. It's called student T distribution. Let's look at this graph. This green curve is the standard normal distribution, the one with the z-scores. The red one is the student T distribution with n equals 12, and the blue curve is the student T distribution with n equals 3. You can tell student T distributions are still bell curves. And the curves are different with different values of n. In fact, the greater the n is, the closer the student T distribution is to the standard normal distribution. Another thing we can tell from this graph is, same as the standard normal distribution, the mean of every student T distribution has a mean of 0. So every student T distribution, the middle number is 0, which is the mean of that distribution. How do we find T alpha over 2? We talk about what alpha is in a confidence interval. Alpha is the area in the two tails. Say we're constructing a confidence interval with confidence level of 95%. And what is the alpha value? Alpha is 1 minus the confidence level, which is in this case 0.95, and alpha is 0.05. And this 0.05 is the area, the total area in both tails. That means the area in each tail is 0.025. And T alpha over 2 is this value. The value to the right of this T value, the area is 0.025, or alpha over 2. We can find this value in this text. We'll call it A3 table, which is the T distribution table. This is the A3 table, which is the T distribution table with critical T values. And on top, you can see here it says area in one tail, area in two tails. So we will do area in two tails, and our alpha value is 0.05 here, right in the middle. And on the column on the very left, you can see something says degrees of freedom. What are those? Well, degree of freedom is just your sample size minus 1, which is n minus 1. So degree of freedom is sample size minus 1, n minus 1. Let's say our n is 20. Then the degree of freedom will be 20 minus 1, which is 19. Okay, so say our problem is find T alpha over 2 with sample size of 20 and confidence level of 95%. Let's go through the chart and see what is this T alpha over 2. And remember, the degree of freedom is 19, and we are going to area in two tails, or area in one tail is 0.025, whichever, it's the same column, right? So over here, you can find the T alpha over 2 we're looking for is 2.093. 2.093. Okay, let's look at this problem. A clinical trial was conducted to test the effectiveness of a drug for treating insomnia in older subjects. Before treatment, 13 subjects had a mean wake time of 100 minutes after, 100 minutes. After treatment, the 13 subjects had a mean wake time of 73.1 minutes and a standard deviation of 22.2 minutes. Assume that the 13 sample values appear to be from a normally distributed population and construct a 99% confidence interval estimate of the mean wake time for a population with drug treatment. Let's look at the first problem first. Okay, construct the 99% confidence interval. Since we're trying to estimate the mean wake time for a population with treatment, now let's look at the sample with treatment. So the sample, this is the sample size. Where is it? 13 subjects. Right, so here it says after treatment. So those are with treatment. 13 subject, this is our n, right? And it has a mean wake time of 73.1. So our mean, sample mean is 73.1, and standard deviation of 22.2. This 22.2 will be the sample standard deviation, which is S. And we know for this confidence interval, the center will be the best point estimate, which is the sample mean, right? And the confidence interval will be the sample mean minus E, which is the margin of error, to the sample mean plus E. All right, So how do we calculate the E? Well, we use this formula. E equals T alpha over 2 times S divided by square root of N. First, let's try to find this T alpha over 2. To find the T alpha over 2, first you have to know alpha, and another thing you need to know is degree of freedom, right? Degree of freedom here is n minus 1, which is 13 minus 1, which is 12. Okay, we got degree of freedom. What is this alpha? Well, the alpha is 1 minus the confidence level. Our confidence level is 99%, so our alpha should be 0.01. Okay, so we have those two values settled. Now let's go to the chart and find this T alpha over 2. Okay, so here is the T distribution table. We know the degree of freedom is 12, which is right here. And our alpha is 0.01, so it's the first column here. So the value, the T alpha over 2, we find is 3.055. Okay, so we got the T alpha over 2, 3.055 times, okay, S. S is the sample standard deviation, which is 22.2. And N is the sample size, which is 13. And we plugged all the numbers in. Using a calculator, we can get, I get is if I round it to the nearest tenth, well, nearest hundredth will be 18.81. Then this confidence interval, the lower bound will be X bar, which is the sample mean, 73.1 minus the E, we just did the calculation, 18 point, I'll do 8, and the upper bound will be 73.1 plus 18.8. Going through the calculation we have, I got 54.3 to 91.9. All right, now let's look at the second question. What does the result suggest about the mean wake time of 100 minutes before the treatment? Does the drug appear to be effective? If you look at this interval does not include this 100 minutes. So the confidence interval does not include 100 minutes. So the mean before and after the treatment are different, right? And the results suggest that the drug treatment has a significant effect. Okay, let's look at before we look at the next problem, let's see if we can do the same problem using StatCrunch. Okay, you go to T-stat, since we're talking about T distribution here. One sample, here we're dealing with summary, so with summary, okay. Sample mean was, let me put the problem this way, the sample mean is 73.1, sample standard deviation is 22.2, the sample size is 13, and we want to construct a confidence interval for the mean, population mean, and the confidence level is 0.99, and then compute. Here you can get the lower limit. If you round to the nearest tenth, it will be 54.3, and upper limit, and round to the nearest tenth, it will be 91.9. Same answer. Now let's look at a slightly different problem. Listed below are the amounts of net worth in millions of dollars of 10 wealthiest celebrities in the country. Construct a 90% confidence interval. What does the result tell us about the population of all celebrities? Do the data appear to be from a normally distributed population as required? Oh, the last one is a question. Do the data appear to be from a normally distributed population as required? Let's find out. Okay, since we're dealing with a set of data, we can use StatCrunch. Open in StatCrunch. So the data will be put in StatCrunch in a row. And we go to Stat, T-Stat. And one sample here is with summary. Sorry, it's not with summary, with data. So T-Stat, one sample with data. I choose the column of the data, variable 1, and pick the confidence interval for mu. The confidence level is 90%. So level 0.90. Okay, and then compute. Okay, here we got the lower limit and the upper limit. Lower limit is 155 point, what does this say? Round to the 1 decimal places that's needed. So 0.5, and the upper limit is 197.9. The next question, what does the result tell us about the population of celebrities? Select one correct choice below. If necessary, fill in the answer box to complete your choice. Okay, so what does this confidence interval mean here? The confidence interval here means we are 90% confident that this interval will contain the real mean of the, what would we call it, income of celebrities. So here we will choose C. We are 90% confident that the interval from this number 155.5 to 197.9 million actually contains the true mean net worth of all celebrities. Okay, before I check my answer, I need to check the requirement. Is it from a normally distributed population? They didn't tell us. And is our n greater than 30? How many is this? 2, 3, 4, 5, 6, 7, 8, 9. Well, definitely less than 30, right? So probably we can't choose C because it didn't meet the requirement. So we will choose B. Okay, so B is the answer. C is not, because this problem doesn't meet the two requirements. First is the population must be from a normally distributed population, or your sample size should be greater than 30. So none of the requirements are met. So you can't actually use this method to estimate. Okay, the last question, do the data appear to be from a normally distributed population as required? Here we will look at something called the normal quintile plot. In StatCrunch, it's called the QQ plot, or it's very similar to the QQ plot in StatCrunch. So you can go to StatCrunch, go through the same process, and over here you pick the QQ plot. This will help us just to decide if the data is from a normally distributed population. So compute, and you can see here not only we have the confidence interval here, on the second page you will have a QQ plot. normal quantile plot. And is it a straight line? Kind of a straight line, but being a straight line is not good enough. If it's a straight line, that means it's from a normally distributed population, but it seems it's a curve of a certain pattern here. So you will choose no, even though it's reasonable straight, close to a straight line, but there is a systematic pattern that is not a straight line pattern. So you will choose A for the for the third question. So this shows that the sample is not from a normally distributed population.